Welcome to the video lesson on graphing the greatest integer function. So how does one graph such a thing? First, I'll show you what a basic greatest integer function looks like. So without any of the bells and whistles, just the f of x, the function is equal to the greatest integer of x. So let's take a look quickly at a table of values. The numbers are very condensed. I'm looking at numbers all between 0 and 1.5. But if x was 0, the greatest integer of 0 is 0. It's already an integer. And the greatest integer of, so f of 0.1 means the greatest integer of 0.1. And remember that these brackets mean round down to the integer below that value. And that means 0. The greatest integer of 0.2 is 0. The greatest integer of 0.9, the integer just below that, is 0. And only at 1 does the greatest integer of 1 become 1. And then the greatest integer of 1.5 is also 1. It gets rounded down. You're always rounding down to the integer below the value that you plugged in. So what does that look like graphically? Well, we said that f of 0 and 0.1, 0.2, 0.3, like anything up till 0.99999999999, those, all of those things are going to have a value of 0. And only when we get to 1 does the function jump up a full step to 1. And then all of the values across that step would be 1, 2 until you get to 2. The way we draw that is like this. We have an open circle here and a closed circle here. This closed circle means that it is included. It means that f of 0 is 0. The function has a value here. And you draw a line to show that all of this stuff is included. But this open circle just indicates that exactly at 1, if you tried to plug in 1, it would no longer have a value of 0. There, rather, I would jump up to where the filled circle is, and it means that f of 1 is 1, and f of 1.1, 1.2, everything up until 1.9999999. And when I get to 2, f of 2 is 2. And I keep going like that. So this is what the basic greatest integer function looks like. And in general, there are parameters that influence what the steps look like, how long they are, how tall they are. It is possible to change from having a filled-in circle on this side to having it on the other side. It's possible that the steps don't have to go up. They can go down going from left to right. All of these things are editable. And just I'll show you what those look like, but just very quickly, the stuff that's true about this function is true about any function. Like we could still answer questions about the domain. The domain of this function would keep going, and this step goes from here all the way until this point and then jumps up here, but that x value is still included, and it goes all the way across, and then that x value is included. The domain is all real numbers. The range, however, is a little bit trickier because these interval brackets imply that every number in between the two endpoints of the interval are part of the answer or set you're talking about. And here in the range, they are not. The range skips over values. 0 is a value, then it jumps to 1, then it jumps to 2. 1.5 is never reached on the y-axis. So I can, in this case, say that it's all whole number, z, or I could write this out, squiggly bracket, dot, 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 -1, 0, 1, dot, dot, dot. That's an okay way to write the answer as well. What are the zeros here? Well, the zeros go all the way from this point until 1 where it's excluded. That entire step is an x-intercept. They're all x-intercepts. Maximum value, there is none. Minimum, there is none. Where is this function increasing? Well, because even though it's made up of horizontal segments, the trend from left to right is that this graph is increasing, which means it's never decreasing. Where is it positive? Well, remember that positive includes 0. It starts being positive right here at 0 and keeps being positive for x values to the right. And it was negative from negative infinity up until 0. Actually, that's not true. This should be negative actually until 1 excluded. Because I'll just fix that right now. Because negative also includes, I'll put that back up. The negative also includes where the function is on the axis. So it's actually negative all the way up until this point, but not including, like it's still negative here. It would be strictly negative only until here, but it keeps being negative until here. So those are some of the properties of the functions. And quickly, I just wanted to show you, generally speaking, these are the parameters of a greatest integer function. And there will be another video that shows you some examples of graphing videos. But I just want to show you very quickly what exactly these things do. There's a number outside, that's the a, b, and then brackets x minus h plus k. There's an hk just like in a quadratic function. H is a fixed negative. And I'll show you quickly what those different parameters do. What do they look like? So you might be able to see here, as I change this, you can't see that, but this is my a value. As I make the a value bigger, that is changing the step height. And if I make it smaller, the height gets smaller and smaller and smaller. If I make it a bigger value, the spacing between the steps gets bigger. This is my b value. If I make my b value bigger, the steps get smaller. If I make my b value smaller and smaller, the steps get bigger. And these are positive numbers. If I make it a negative number, what happens is the steps change which side is open. Normally they open on the right. Well, normally, that's what we had seen. If I change this to a negative number, then they open on the other side. My h value does the same thing as it did in a quadratic. It moves the fixed dot right and left, and the k value moves it up and down. So these do similar things to in a quadratic function. And if you want to see some examples of graphed functions, that will be in another video.